So now we need to get a good idea of how we solve a rational equation in one variable. So how do we solve for x if our x is on the bottom of a fraction? So the very first thing I'm going to do is actually isolate my fraction here. So I'm going to add a 2 on both sides so that my fraction is isolated. And what I want to be able to do now is to change the placement of that x so that it's no longer on the denominator of a fraction. And how will I do that? I'm going to multiply both sides by something that will cancel it out. So what ends up happening? These two terms cancel each other because they're divide into each other to leave me with 1. And I have 2x minus 1 times by 7 is equal to 3. And then I just distribute, so 2x times 7 gives me a 14x, negative 1 times 7 gives me a negative 1, equals 3. 14x equals a positive 10, and then I'll divide both sides by 14 to give me 10 over 14. So it's very straightforward, and you've probably done quite a few examples like this before. So we'll switch our focus now to how do we solve an inequality when we have a fraction. So when our x is on the bottom of a fraction. So we'll isolate our fraction if we need to. I'm stuttering a lot today for no apparent reason. But in this case, we actually don't need to. So we have it isolated already. What I'd like to do now is to solve the equality. So I'll replace it with an equal sign. And it says here, taking restrictions into account. And what I mean by that is figure out what values you cannot have for x. So what value of x will actually leave you with something that's undefined? What do I mean by that? I mean, what value will leave me with a 0 on the denominator? So if I look at this here, 5 take away x. Well, if x is equal to 5, I end up with something that's undefined. So x cannot equal 5. That's an important value. We're going to keep that up there, and we're actually going to solve our equality just like we did in our previous example. So 3 over 5 minus x is equal to 2. Multiply both sides here by 5 minus x. And that leaves me with this here. Okay. I'm going to do a little bit of solving. I didn't space this out very well. So I end up with a negative 2x is equal to a negative 7. So x is equal to 3.5. So now that I know that my value of x is 3.5, what I'm going to do is actually set it up on a number line. So I'm going to represent my critical values on a number line. So let's write this down. Our two critical values are x at 3.5 and x at 5. And we're going to represent with an open circle or a closed circle depending on the situation. So I'm going to put a line here, and we'll say that that is x equals 5. And I'm going to write an open circle here because x cannot equal 5. And then if this is 3.5, I'm going to color it in because I have greater than or equal to in my inequality. And what I want to do now is to actually just use a test point. If I use a test point, I should be able to figure out if my inequality is true for that region. So I'll choose a test point that's in the middle. I'll choose, let's say, x equals 4. And I'll replace x with 4 in my inequality and see what happens. So I'm back to my original inequality. I end up with 3 over 1 is greater than or equal to 2. Well, that's just 3 is greater than or equal to 2, and that's actually true. So my answers are in here. So my value of x as a final answer, I'll write it down here in the corner. My value of x can be greater than or equal to 3.5, but my value of x has to be less than 5.